The inert pair effect. The formal definition of the inert pair effect is the tendency of the outermost s electrons to not participate in chemical reactions for post-transitional metals. Now, what is the practical upshot of this? Well, in this area of the periodic table that you see right here, which we would call the post-transitional metals, they tend to have two possible charges, which are spaced 2 apart from each other. So here you see 1 and 3, 1 and 3, 2 and 4, 2 and 4, 3 and 5, 3 and 5. This will be a relatively short video with one goal. Look at this block of 6 elements on the periodic table, check out the pattern of charges. These are the charges that you do have to know, and memorizing them off a boring list with no context makes that pretty hard to do. But we can use electron configurations to help explain them. This not only teaches us why these elements have this pattern of 2 charges that are 2 apart, but also helps us remember them, since now you can use the periodic table as a cheat sheet. And as I mentioned in the previous slide, this is called the inert pair effect. So we talked about how they are separated by 2, but of course that doesn't mean they are all the same charges. We have a 1 and 3 in a column, a 2 and 4 in a column, and a 3 and 5 in the next. And let's look at why this occurs by writing out some of the electron configurations. Let's look at antimony and lead as our 2 examples. Neutral antimony has the following electron configuration. Let's think about how that can reach a stable electron configuration. If we remove the 3 electrons that are in the 5p orbital, this leaves us with both subshells filled. This is relatively stable. However, we could also take off the 5s electrons, leaving both the s and the p orbitals empty. This is also a stable electron configuration. We'll do one more example. Let's look at lead. It may be a good idea to pause and see if you can get this one correct on your own first. We'll start by writing out the electron configuration for neutral lead. This leaves us with the following. Remember, if you are having trouble writing out electron configurations, you want to go back and watch the video that I made on that, and I'll link that at the end. Now this leaves us with the following. We can remove the 2 electrons in the 6p orbital, which leaves us with a charge of +2. Or we can also remove the 2 electrons in the 6s orbital, leaving us with a +4 overall. As your homework and understanding check to this video, write out the electron configurations for every other one of these ions shown here, and then use the electron configuration to explain the ions that they form. And use this to help you memorize these ions. So with this video, you hopefully now understand this pattern that exists within the periodic table. This should help you remember these elements during our naming and formula making processes as well. And you should also know that this is caused by the inert pair effect, though we didn't go into exactly why that effect happens and a lot of the details of that, which goes a little beyond the scope of this class.